as 50th point. Okay. Yeah, we have 6 trigonometric ratios. We need to sketch 6 graphs. Drawing a graph for any expression, for any function, not only trigonometry, for anything, if drawing a graph is nothing but analyzing one variable with respect to the other variable. Okay, analyzing the behavior of one variable with respect to the behavior of another variable is nothing but just sketching the graph. And here y is equals to sin x, or you may say sin theta, no problem. Okay, usually while sketching the graph we use two variables as y and x. Among those y and x is the independent variable, whereas y is the dependent variable on that x. Yeah, why we are calling x as independent variable and why we are calling y as dependent variable? Because we have independent chance to take any angle in the place of x. You can take any angle in the place of x. Okay, it's an independent choice for you. But depending on those values of x, you will get different y values. Now we are going to draw the graph by taking their corresponding x values on the x-axis and corresponding y values on the y-axis. Right? See, this horizontal line is the x-axis and this vertical line is the y-axis, whereas this point is the origin. I think you are all familiar with this. Yeah. Now what we are drawing? See, we need to take angles on the horizontal line. Okay. What I am going to tell you is angles on the horizontal line and the values, real values on the vertical line. That's what you need to mention somewhere. Okay. On x-axis, what we are taking? X values. X values are nothing but what? Angles. And on y-axis, we are taking y values. Y values are nothing but real values, real numbers. Right. By giving different angles, different values of angles for x, always you will get different real values for y. And now on x-axis you need to indicate, yeah, some angles. Okay, this is 0 degrees. Okay, and somewhere you will get 90 degrees, pi by 2, and after that pi is 180 degrees, and after that 3 pi by 2 is 270 degrees, and then 2 pi is 360 degrees, and after that 2 pi plus pi by 2 is what? 5 pi by 2. Okay, still we have some more angles that side. And coming to the negative direction, this is minus 90 degrees, and this is minus 180 degrees, and this is minus 3 pi by 2, and this is minus 2 pi, and if you extend it, somewhere you will get minus 5 pi by 2, and so on. So this direction you will get negative angles, in that direction you will get positive angles. Right. We learnt about the nature of sin x. In which quadrant the sine function is increasing and in which quadrant it is decreasing, and where the sine function is positive and where the sine function is negative. We learnt already about all these things: the positive and negative nature of the sine function, the increasing and decreasing nature of the sine function depending upon the quadrants. In the similar way, we already know the values of sine function for different angles. Based on those angles, based on the nature of the sine, we are going to sketch the graph. Now look there. See, as we discussed in the last class, for any given angle, the sine values are always in between minus 1 and 1. So, since the sine values, what is sine here? Sine x is here y. So, since sine x values are in between minus 1 and 1, here y values are in between minus 1 and 1. Y values always lies on y axis. So, you need to look at, yeah, 1 and minus 1 on y axis. Okay. Somewhere you will take 1 on this y-axis and minus 1 on this y-axis. So you will get 2, 3, 4 like that, minus 2, minus 3, 4 in the downside of this y-axis. So always the graph is in between minus 1 and 1. Since the range of sin x is in between minus 1 and 1, the graph for sure includes in between minus 1 and 1. It won't exceeds the minus 1 and 1. So if you sketch an imaginary line at minus 1 and 1, for suppose this is my imaginary line at 1. Okay, and for suppose if you take an imaginary line at minus 1, this line is not a graph, this is just an imaginary line. Yeah, and now try to sketch the graph. Yeah, right. See, what is 0 degrees? Sine 0 degrees is 0, sine 90 degrees is 1. So at pi by 2 the graph value is 1. So at pi by 2 we need to, the value of y is 1. So 90 degrees and 1, 180 degrees and 0. See, look there, sine 0 degrees is 0, sine 90 degrees is 1, sine 180 degrees is 0. So, from 0 to 180, the sine graph will be like this. And it is very clear that 0 to pi by 2 means first quadrant. In first quadrant, sine function is increasing, and pi by 2 pi means decreasing. Already we know it. Again from pi to 3 pi by 2. Sine pi the value is 0, sine 3 pi by 2 the value is minus 1. So at 270 degrees the graph is at minus 1, so it continues like that. And after from 270 to 360, sine 360 degrees is again 0, and it again increases like this. And again 2 pi to 5 by 2, 360 degrees and 450 degrees, which lies again in the quadrant, first quadrant. Again in first quadrant from 0 to 1 it rises, so again the graph will be like this, and it continues like a curve. Whereas coming to this side, sine 0 degrees is 0, it is very clear. Just you follow the values. What you say about sine of minus 90 degrees? We know that sine of minus theta is minus sine theta. So sine of minus pi by 2 is minus sine pi by 2. So sine of minus pi by 2 is minus 1. And sine of minus pi is 0. So the graph continues like this. And from there minus pi to minus 3 pi by 2. Minus 180 degrees, minus 270 degrees. You need to identify the values. Sine of minus theta is minus sine theta. So minus sine of 3 pi by 2 is 1, and it is again 0, and the graph continues like this. Okay. So if you look at the graph, always the sine function is just like a wave curve. Okay. And the curve is moving like that. And the graph surely bounded in between 1 and minus 1. On x-axis we are taking the angles, on y-axis we are observing the real values, and we are giving for x the real angles. So that x, we call those x as the inputs, and those inputs already we mentioned as domain. So the domain of the function, the inputs of the function, the x values are lying on the horizontal line, and the ranges, the resultant values and the y values will lie on the y-axis. So it surely lies in between minus 1 and 1, and the graph looks like a wave curve. It continues like that. Just have a look at this. This is the graph of sin x, and similar to this, now we need to sketch the graphs for cos, tan, cot, cosecant and everything. Have a look at this. And one more thing, in sketching the graphs, always the peaks should be smooth peaks, okay? That in the sense, here we have peaks, right? Turning points, or you may say peak points. The peaks should be smooth, okay? You don't draw V-shaped peaks. You need to draw always U-shaped peaks, that's it, okay? We call them as smooth peaks, right? Look at the graph and think about cos x. Now, see, it's the time for cos x to sketch the graph. Again for cos x also we will give different real angles in the place of x. Always you will get different resultant y values, and you need to indicate the real angles what we are giving for x on x axis, and the real values what we are getting from sin x we are getting for y on y axis. And we know that cos x values are also in between 1 and minus 1, because its range is again in between 1 and minus 1. So somewhere you just indicate 1 and minus 1 below the x axis. So if you sketch the graph just like of sin x, here also the sketch of cos x, the graph of cos x always lies in between minus 1 and 1. So for that you just try to imagine a line at 1. Okay, actually this line is not that much of compulsory, right? But just we are sketching the graph. See, we draw such that it must be fitted in between this 1 and minus 1. For that sketch, just I am utilizing an imaginary lines at 1 and minus 1. Again, to sketch the graph, we need to think about the increasing and decreasing nature of the cos x, as well as the positive and negative nature of cos x, along with the trigonometric values of cos x for the known angles. And we know that what you know that cos 0 degrees is how much? Cos 0 degrees is 1. So for this real angle, its result is 1, and for cos 90 degrees, it is 0. So the graph surely passes through this. So in first quadrant, while moving from 0 to pi by 2, cos values will decrease from 1 to 0. I think you know that. X values are changing from 0 to pi by 2, and this red color line indicates the y values will decrease from 1 to 0. Whereas sin 180 degrees is how much? Sin 180 degrees is minus 1, and again sin 3 pi by 2 is 0. So the graph will continue like this. Again sin 360 degrees is again 1, and sin this 5 pi by 2 is again 0. Okay, you need to mark this as 5 pi by 2 like that. Okay, again you will get a wave curve shape. Okay, Again this sine of minus pi by 2 is 0, sine of minus pi is minus 1, and then cos, right, cos of minus 3 pi by 2, cos of 2 pi, and cos of minus 5 pi by 2, and the graph will be like this. Always you need to identify the cos values at these angles, and with those values just it is a rough sketch for the graph. And if you need to sketch the exact graph for this, go with the graph sheet. Okay, you just take a graph sheet, indicate the angles, and then try to draw the graph. Okay, and now this is just rough sketch. Similar to the sin x, cos x is also a wave curve shape, and here also all the peaks must be smooth. Okay, you don't draw V-shaped curves, turnings. You need to draw only U-shaped turnings. Look, there is a small difference between sin x and cos x. Both are in wave shape, both are in this curvy nature, wave curvy nature, but sin x, it starts from sin 0 degrees and then 1, it moves like that, and cos is start from 1 and then it moves like that. Just you observe those two graphs at a time and you will clearly identify the difference between those two and similarities between those two. And this is the sketch of cos x. Have a look at this, and then we are going to sketch the graphs for tan x, cot x, cosecant x. Those graphs are somewhat different from these two. Okay, and after the completion of this cos x, just think about tan x. That's what we are going to sketch right now on the board. First indicate the angles on x-axis to sketch the graph of tan x. See the same known angles, 0 degrees, and then pi by 2, and then pi, and then 3 pi by 2. After that 2 pi, and add one more pi by 2, it is 5 pi by 2. Still you have many angles that side. And now coming to this side, minus pi by 2, minus pi, minus 3 pi by 2, and then minus 5 pi by 2, and if you move, still you will get many angles in this side. Now we are going to sketch the graph of tan x. You just think about tan x. See, tan x, the range of tan x is from minus infinity to infinity. There is no boundary on y for tan x. Tan x is just nothing but y. Since tan x is from minus infinity to plus infinity, y is also from minus infinity to plus infinity. Whereas sin x and cos x values will lie in between minus 1 and 1. There is a boundary. The minimum value is minus 1 and the maximum value is 1. But whereas coming to the tan x, there is no such boundary. Minimum we can't determine, maximum also we can't determine. So the graph continuously moves like that, as well as the graph continuously comes from that direction. And we know that the increasing and decreasing nature of tan x. And what it is? Tan function is always increasing. In any quadrant, if you raise the angles, the tan x values also will rise, because tan x is always increasing. And also we know that the tan x is positive in first and third quadrants, whereas negative in second and fourth quadrants. With this complete information, along with the values of tan x for the known angles, we are going to sketch the graph. Just come with me how to sketch. See, actually as I told you, there is no boundary for tan x, so no need to draw the imaginary lines at 1 and minus 1 like for sin and cos. No need to draw those imaginary lines here. But what to draw here it is, because what is the value of tan 90 degrees? See, first of all think there, then automatically you will get an idea. Tan 0 degrees is how much? 0. It's very clear. But tan 90 degrees is how much? Tan 90 degrees is infinity. Since tan 90 degrees is infinity, it is very difficult to indicate infinity on the graph, on the plane. Okay, so since it is not possible to indicate infinity on the plane, on the graph, so you need to draw imaginary lines at those angles where tan function is infinity. So here it is one imaginary line, and then at 3 pi by 2 you need to sketch one more imaginary line, and again at 5 pi by 2 you need to sketch one more imaginary line. Likewise in this direction also, at minus pi by 2 you just sketch one imaginary line, and then at minus 3 pi by 2 you just sketch one more imaginary line. As I told you, in the domain of x, see, x-axis on the horizontal line, we are taking the inputs for angles, and those inputs are termed as the domain also. In the previous points, the previous sessions, most probably I mentioned you, the domain of tan x is the all real angles except the odd multiples of 90. Because at 90 degrees, 270 degrees, 450 degrees, and at all these angles, tan function is not exist, okay, indeterminate. So at these odd multiples of 90 degrees, the graph won't exist. So you need to leave a space there for the graph. So that's why to leave that space, initially we are drawing certain barriers there. See certain imaginary lines. And now look at the graph from 0 to pi by 2 in the first quadrant. Tan 0 degrees is 0, tan 90 degrees is 1. See, not infinity, right? Tan 0 is 0, tan 90 is infinity. Starting from 0, we need to move this red color line, the graph, to the infinity, right? It is not possible, right? So somewhere we draw like that and indicate it by an arrow. And again, see at 90 degrees the value won't exist. That's why this red color line and this blue color line won't meet. If you look there, they appears in such a manner, maybe they meet at some point, okay? But actual thing is those two lines won't meet at any space in that direction, okay? Because tan 90 degrees is unknown value, indeterminate. This red color indicates the graphical value. So for something like less than 90 degrees, maybe 89.999999, for that angle you may get a very larger value. So the graph moves like that. But at 90 degrees, the graph just, see, don't crosses this like this blue color line. Right. And again from what you say from 90 to 180. As I told you, 90 degrees to 180 degrees, the graph is what? A negative. See, tan x is negative. So in the negative direction, you need to think the graph comes from the negative larger value to the 0 degrees. Okay. We need to draw a curve shaped thing. Yeah. Like this. Tan 180 degrees is 0. But tan 90 degrees, see, something more than 90 degrees, the tan value is what? Minus infinity. So the graph comes from minus infinity and reaches to 0 at 180. Again from 180 to 3 pi by 2, at 180 it is 0, and again at 3 pi by 2 it is somewhat infinity. So always in each and every range of pi by 2, the graph will be like this. Okay, here also the graph will be like this. It comes from a negative larger value to minus pi, where it is 0, and then it moves to the a positive larger value. Actually this red color part and blue color part won't meet it anywhere. Okay, so this is the sketch of the tan x. So at the end, if you observe, tan x is always increasing, right? See, it starts from there, increasing. At this place it gets cutting, right? See, it is not continuous. The tan x graph is discontinuous actually. The graph is discontinuous at the points where x is odd multiples of 90 degrees. So, and it is discontinuous, and in each and every block of the tan x, the graph is continuously increasing. So, this is the sketch of tan x. And similarly, you can draw the sketch of cot x also. Where the cot x is decreasing function, always you will get a decreasing lines like that. Again, there also you need some imaginary lines at even multiples of 90. But for some time, leave that cot x, you just pay your attention on tan x. To sketch the tan x like sin x and cos x, see, we need to draw imaginary lines at the points where the tan x is not defined. So at odd multiples of 90 it is not defined. So at odd multiples of 90 we need to leave some space. So to indicate that space we are taking these imaginary barriers. So we have at the end, this is a sketch. Tan x is always increasing and tan x is a discontinuous function. Just have a look at this, and then I will come up with the another trigonometric function. Now we are going to sketch the graph of cosecant x, and this graph is much different from sin cos as well as from tan cot, because the values of cosecant x are very variant actually. These values won't lie in between minus 1 and 1. We know that sin x values are in between minus 1 and 1, but the values of cosecant x won't lie in between minus 1 and 1. The values of cosecant x either less than minus 1 or greater than minus 1. Okay, see, we know all these things, the range of cosecant x, the domain of the cosecant x, as well as the positive and negative nature of cosecant x, the increasing and decreasing nature of cosecant x. First of all, you need to indicate the values, the known angles here, 0, pi by 2, pi, and then 3 pi by 2, and then 2 pi, 5 pi by 2. Still you will get some more angles that direction. And here what it is, minus pi by 2, okay, minus pi, and then minus 3 pi by 2, and somewhere you will get minus 2 pi, okay, and here it is minus 5 pi by 2. Yeah, see, in both the direction you need to sketch, and now again you need to indicate the imaginary lines at 1 and minus 1. So on y axis you just take 1 somewhere, and minus 1 somewhere. And you just try to sketch an imaginary line at 1. See, the graph is very critical actually. And again, critical in the sense somewhat logical, right? And again, you just try to draw an imaginary line at minus 1 also. See, for sin x and cos x, the range is in between minus 1 and 1. So, the graph always lies in between minus 1 and 1. The graph just dances in between minus 1 and 1. But whereas coming to the cosecant x, the graph won't lie in between minus 1 and 1 because the range, the values of cosecant x always outside of this region. Always less than this minus 1. Less than minus 1 means the graph lies below this minus 1, and more than 1 means the graph lies above this minus 1. That's one particular idea. That in the sense, in this region, there is no graph of cosecant x. It's just we need to leave this region just like that only. Okay? And again, at some points, the cosecant value is infinity. Again, for the infinity, for the angles where the cosecant x is infinity, there again you need to sketch some more imaginary lines. See, sine 0 degrees is 0, cosecant 0 degrees is infinity. So at 0 degrees already the line is there. And sine 180 degrees is again 0, cosecant 180 degrees is again infinity. So at 180 degrees, again you need to sketch one imaginary line because infinity we can't indicate it on the graph paper. Okay, so this is one imaginary line. Again at 360 degrees, sine 360 degrees is 0, cosecant 360 degrees is again infinity. So at 360 also we need to sketch one imaginary. Whereas coming to this direction, at minus pi, one imaginary line, at minus 2 pi, another imaginary line. See, at the end you need to draw vertical imaginary lines at the angles where the given trigonometric function leaves us an infinity, an unknown indeterminate value. For those angles we are taking the vertical imaginary lines. Now coming to the sketch of the graph, see, cosecant 0 degrees is infinity and cosecant 90 degrees is 1. That's what you need to identify. Sine 90 degrees is 1, cosecant 90 is also 1. At 90 degrees the graph should meet at this point, but at 0 the graph may start at infinity and it decreases like that up to 90 and then it moves. So in this particular region the graph lies like this. Again in between 180 to 360 the cosecant is in the negative region, so at minus 3 pi by 2 it touches minus 1 and it moves like that. So it is a piecewise graph, discontinuous piecewise. There one piece, here one piece, and again 2 pi to 3 pi the graph will be like this. At 5 pi by 2 it is 1 actually, the value. So the graph will be like this. Again now coming to this, 0 to minus pi. 0 to minus pi means which quadrants? Third quadrant and fourth quadrant. In third and fourth quadrants the graph is negative. So again you need to sketch a graph in this region like that. At minus 90 it is minus 1. Again minus 2 pi to minus pi the graph will be like this. Okay, just observe it. Okay, you will get these graphs in each and every standard book again. If you still have any confusion in drawing or if you have any problem related to the screen, you just go through those standard books. Okay, I think they provide, see, once look there, this is the sketch of cosecant x. Similar to cosecant x we can draw the graph for secant x also. For secant x also the same pattern. In between 1 and minus 1 there is no graph. So look there is no red color line in between minus 1 and 1 because cosecant x and secant x won't give the values in between minus 1 and 1. And always the graph is either less than minus 1 or either greater than 1. So you need to memorize this graph, and now we sketched it just by observing the nature of cosecant x. Where it is increasing, where it is decreasing, where it is positive, where it is negative, and what you say about cosecant x. It is a reciprocal of sin x. And what are the values of cosecant x? We know those values where it is infinity and where it is 0, where it is 1. With all these things, now it is possible. See, we have this possibility of sketching the graph of cosecant x. Have a look at this, and then you just try to draw the sketch of secant x. See, now totally there are 6 trigonometric functions. Already I mentioned you 4 graphs on the board, and now it is your turn. You need to sketch the graph of cot x and secant x. At the end you need to memorize all these graphs. In particularly, in most of the cases, we use usually the graphs of sine, cos and tan repeatedly. And sometimes we will use the graphs of cot, secant, cosecant also. But among these 6, sine, cos, tan are somewhat important in problems point of view. Okay, just have a look at this, and these are the graphs for the trigonometric functions.